Okay, 2016 MCQ number 31, right? The answer, as I have told you already, is number 2. Let us discuss how it comes, right? So the question is, the limiting frictional force between two objects with rough surfaces in contact depends on. Now, when you read the question, right, just try to identify what are the keywords in the question that makes you understand it and also takes your brain to the appropriate unit in the book, right? In this case, there are two keywords in the question itself, that is limiting frictional force or limiting friction and depends, right? So when we talk about limiting friction, we know that limiting friction is the maximum friction between two surfaces in contact with each other, right? So in other words, limiting friction is also the maximum frictional force between two surfaces in contact with each other when the objects are just started moving, right? When the objects are just started moving, right? So there are three factors affecting limiting friction. You can check in the book, and also those who have done the mind map, they can check it in their mind maps. So those factors are the nature of the surfaces, the normal reaction, and the area of the surfaces in touch with each other, right? So the limiting friction actually depends on two factors. That is the nature of the surfaces, whether they are rough or smooth, and also the normal reaction on the surface, that is normally the weight exerted by the gravitational force on those objects, right? So the limiting frictional force doesn't depend on the area in contact with the surface. For example, if you have a brick of stone, right, so this area, this flat area will be more, right? So you can place it on a table and pull it. Again, you can turn it, flip it over, so that it will touch the less area side of the table and pull it. In both cases, the pulling force to break the friction or to overcome the static friction or to just start the object to move is the same, right, regardless of the area. You can check it out in your book, it's all there in the book. So from that we understand that area doesn't have any effect on the limiting friction, so you can cut off or you can eliminate all the answers which contains the word area, right? 1, 2 and 3, here we go. Then you have number 2. Okay, let us go to the 2017 essay paper number 2, question number 7, part 4, A and B. All right. So whenever you see questions like this, you have to read it at least twice. That's a key point, right? So in this case, I have two options. I can make the video very short by giving you the answers and continuing just a normal explanation, or I can give you, like I said in the previous video, I can give you a fishing rod and teach you how to fish. That means I can teach you to train your brain so that you can answer questions like this type anywhere in the world or in any exam that you encounter, right? So this should be our goal. That means to train your brain so that you don't fail trying to answer these type of questions. All right, so this question, the first part of the question has a small story in it, right? Let me read it out for you. In heavy rainy days, the drivers are advised to maintain 15 ms minus 1 as the maximum velocity for a vehicle that is driven on the expressway mentioned in number 3 above, right? So that tries, the question itself tries to join you towards the previous question, right? So that makes a false sense, or that creates some kind of a suspicion in you that if you were not able to find the answer in number 3 above, you will fail finding the answer in this as well. That is not the case. If you look closely, this is a general knowledge question, right? This has nothing to do with the previous question. Whether you found the answer for it or didn't find the answer for it, that doesn't really matter here. Why does it matter is because they think that the person who has made this paper thinks that we are from Nigeria, right? So we are not from Nigeria, we are from Sri Lanka, we have brains, we can think very straight, right? So if you can think very straight, that means you will understand that this part, right, this part is not necessary in order to answer this question, right? So now let me come down to the general knowledge question. Letter A and letter B. Letter A gives you 1 mark and letter B gives you 2 marks, all right? That is out of 200. That means 1 mark out of 200 and 2 marks out of 200, A and B respectively. This asks you what is the main reason. This is a general knowledge question, right? Think rationally, use your brain. This is where you train your brain to think one step further, right? This is where you come ahead of the game, right? So when you can think rationally, when you can reason this, that means you won this, you are halfway through. What is the main reason for advising the drivers not to drive? Not is highlighted once again. It's helping you, right? To drive the vehicles at a higher velocity when heavy rain exists. So this is a general knowledge question. This says that why people are advised not to drive at higher speeds when there's heavy rain. That is in basic terms, if I put into basic words, right? So what is the story which tells you before? Like in the explanation, in every rainy days, they are talking about the previous highways, and they are giving you numbers like 15 ms -1, and they are giving you words like maximum velocity, trying to take you on a ride, trying to make you confused. So you have to be clear, right? You have to think. You have to calm down and think that this has nothing to do with the previous one. So this is general knowledge. So why are we telling the drivers to drive slowly or not to drive faster on heavy rainy days? Why? Because the roads are slippery. Basic, right? The roads are slippery. We call it in other terms, when it comes to vehicles, we call them as skidding, not slipping. Vehicles don't slip, they skid. That means their tires stop rotating, and then they just slide through the road, and the drivers lose control on the vehicles. So they might go and hit something, right? Hit another vehicle, hit a passenger, hit a curb, hit a pole or something like that, right? So there's only 1 mark about it in this question. From that you will have an answer. A very short answer is what they are expecting. Due to, I use the word due to. You can write because of also. Because of or due to skidding or slipping, or due to slipping, or we can say due to skidding of vehicles, or it can cause accidents. Basically all those answers are correct. Okay. And also the second one, explain scientifically. Now it comes the small explanation part. Explain scientifically your answer in A before. Now you already know that the vehicles tend to slip or skid during heavy rainy days, right? So now what is the reason for vehicles to slip on heavy rainy days? Then you must be able to understand that they are talking about friction here. They are talking about reduced friction here, right? So friction is friction is the force which acts between two surfaces to resist movement, right? So now in this case, the vehicles, the tires of the vehicle and the road itself are in contact with each other, and when there's good grip, the vehicles don't slip, right? So that means there's more friction. And when there's rain, there's water on the road, so that means there's a less friction, or the vehicles tend to slip, right? So any answer that says that friction is less between the tires of the vehicle and the road is correct. So I wrote like this, because the friction between the tires and the road is less or low on rainy days. Simple as that. Okay, let's come to the 2018 paper. That is the final question we'll be discussing on friction today. Why? Because we don't have the 2019 paper yet. All right. Okay. Anyway, I'm not sure if they have a friction question in 2019 paper. Anyway, we expect there to be a friction related question this year. So that is the reason I chose this topic. All right. So the seventh question, 2018. This shows you a graph. All right. So the previous question before that gives you another idea of solving a little sums, but in this case that doesn't, once again I'm telling you, the previous questions or its answers have no relation to this question, right? So let me just I just drew it for you, the object over here, because there's no space here to copy the full image. Alright, so this, you can see, this is the X force. There's an object on a table, right? This is the surface of the table, so there's X here, right? X is the force, that there's a Newton balance here. This has been mentioned in the note. You can go back and read the question itself. Alright, so there's a Newton balance here, and X is applied in this direction, and obviously there's a frictional force which is resisting the force X in the opposite direction, right? Okay, so we need to understand the behavior of this graph before we can move on to the question, right? So now you can see that X is the force that is given pulling from the object from left to right, and friction is the force that is pulling the object from right to left, right? So they are acting in opposite directions. And what does the Newton's first law say? They say that when there is a balanced force, equal and opposite in directions, there is no movement. Or in other words, they say that there is movement when there is unbalanced force. There is movement in that particular direction where the unbalanced force is acting, right? So that is basically Newton's first law of motion. Alright, so we need to understand that basically in order to identify the behavior of this graph. This is basically a friction graph, right? So what happens is, okay, let me explain you step by step this graph. Alright, so let's say, okay, here is X, the force gradually means step by step, and here's friction, right? So they have the friction against X, which is the force, that is external force given to the object. So when the external force is 1, the friction is also 1. So that means they act in opposite directions. Imagine two people, identical people, having same power, same strength, pulling each other, using same power, same strength in different directions. What will happen to both of them? Are they moving? No, they won't move. Right? Same like that, we can see that if the X was 1, the friction is also 1. That means they act in opposite directions, so they cancel out, and there's no movement. Similarly, when the X is number 2, the frictional force also becomes number 2. Right over here, check the dots that I'm marking right now. If you don't see this, you can copy the graph in another paper and just follow through this. All right, then when the friction is 2, when the X force, external force is 2, the friction also becomes 2. That means we can understand that both of them are acting in opposite directions, and they are equal, and they cancel out. There's no movement, right? And when there's 3, let me come to the question next. When there's 3, the friction is also 3, right? So that means, again, do you think there's movement? Because the friction is 3, this side the force is 3, and this direction the force is 3. So X is equal to 3, and friction is F is equal to also 3. So do you think there's movement here? I don't think there's a movement here. Why? Because both the forces acting opposite directions, and they cancel out, right? They are equal. Okay, so let me come to the question now. By what name is the frictional force exerted on the block of wood known when the force X exerted on it is 3 Newton? So I'm going to X here, 3 Newton. Frictional force is also 3 Newton. And what is the name of that frictional force? Okay, we know that there's no movement here, right? Why? Because the friction is also equal, the X pulling force is also equal. So they are in opposite directions, so they cancel out, right? There's no movement. And what is the frictional force when there's no movement? That is called static friction, right? Very simple. Okay, then let me come to the part B, right? So we know that static friction means when the frictional forces acting upon those objects when the objects are not moving. There's no relative motion. And this asks you, what is the limiting frictional force exerted on the block of wood as indicated in the graph? Alright, now we know that limiting frictional force is also the maximum frictional force acting upon two bodies when they are just about to move, right? The maximum frictional force. Okay, out of this F, you go to the maximum point where the F is there, that is 4 newtons, right? That is called the limiting frictional force, right? So we can say that it's 4 newtons. Okay, the maximum frictional force is also called the limiting frictional force. So that is 4 newton, and make sure you write the units. Without the units, the answer will not be acceptable, right? So let me come to the fourth part. It was required to drag a large block of wood along a flat, rough surface, flat and rough, maybe gravel, maybe a road with a lot of a rough road, right? So state 2 different methods that can be used to reduce the friction between those surfaces. All right. Now they want to pull a large block of wood along a road, a flat road anyway. All right. So they are asking for a practical solution here. What can you do practically to reduce friction or to make it easy to pull the block of wood along the road? Let me explain you. By smoothing the, I chose by smoothing the ground using sand. You can bring some smooth sand and put it on the floor so that it will act as a barrier between the two rough surfaces, and it will make it easy for you to pull it, right? It's like using a lubricant. Okay, you can, if it is a normal surface, you can use like water, oil, or you can use grease or something like that. But in this case, I chose to use sand, which is because the surface is rough. So if I can use some smooth sand or powder or something like that, or let's say flour or kind of thing, you can make it easy. You can reduce the friction between those two surfaces. And also I came up with an idea by using rollers between objects, between the object and the ground. Rollers, that means I can use wooden rollers or metal pipes kind of things. I can put them in between the wooden block and the road, and I can make it easy for the, it acts like a bearing, right? It will take the weight, and the rollers, they roll very easily, so the wooden block can be moved easily. So that's it for today, and we'll come up with some BS questions next time, right? See you guys, take care, bye bye.